Hello and welcome back. Today we're going to be talking about 2.1, section 2.1, which is all about applications of systems of linear equations. So in 2.R we talked about how to solve them using the substitution and elimination method. Now we're going to take these and look about how we can apply that. So let's take an example here and just look at what we have on this. Businesses sometimes will use systems of linear equations to figure out what they call the break-even point. And so with this example, what we're talking about here, this break-even point, is where we have the cost equation, so the equation that makes up all the things that you're going to be spending in your business, and your revenue equation, how much money you're bringing into your business, and the point in which those two lines cross each other is called the break-even point. So anything that is above that, in between these two lines here, is where you're going to see a profit in your business. And if you're below that break-even point, then you're going to be losing money in your business. So when we're looking at this, it's just important to remember this. And so kind of what we can think of for trying to make sense of what this is saying, notice that our graph on the side here is talking about money in hundreds of dollars, and along the bottom, along the x-axis, is quantity in hundreds of units. So we're talking about skateboard manufacturer here, and so we find that if 700 units are produced, they cost $3,300, right? But the revenue is also $3,300 when they sell 700 units. Right? So that's what we're talking about with this break-even point. Now, like I said, this is something that you could see in business, but there's other ways that we can apply and use these systems of linear equations to solve, to figure out something when we have two equations and two variables. So I'm looking at how to go about setting up and solving, figuring out how to solve an application problem involving systems of equations. We first always want to define our variables, right? You'll have two different variables because remember, we're trying to make a system of equations that's in two variables. So we want to define what each of those variables stand for. Then we'll use the words in the problem to help us write two different equations. Then we'll solve those equations using either the substitution or elimination method. Remember, you can graph also, but sometimes graphing has some limitations in being able to figure out exactly where those lines are crossing. Right? And then you always want to make sure at the end, after you solve it, you state your solution with correct units. And after you put those units on, take a look at your answers and make sure they make sense for what it is you're talking about in this problem. Because if you come out with a negative answer for something that can't be negative, it would be a good idea to go back and see, do I have my equations set up correctly, or did I make a mistake in solving them? Okay, let's take a look at this first one. Is it possible for two numbers to have a difference of 8 and a sum of 2? So you could start by thinking about different numbers that would subtract to be 8. Maybe I take 9 minus 1, right? That equals 8. I could have 15 minus 7. That equals 8. Right? I could say 16 minus 8. That equals 8. And so on, right? There's a lot of different possibilities that we could come up with here. But when I'm looking, do any of these add up to be 2? Right? Any of these that I came up with? Well, 9 plus 1 doesn't equal 2. 15 plus 7 doesn't equal 2. 16 plus 8 doesn't equal 2. So I haven't found the right combination there. All right? But setting it up using this way that we've talked about up here will help us be able to find that fairly easily. So let's go ahead and define our variables on this. And I'm going to say x is going to be the first number. And I'm going to call y the second number. Now, just something to note here, since we came out with a positive number when we're subtracting that, that means that that first number must be a larger number. And sometimes that's helpful to think about when you're working through these problems. We've got our variables. Let's go ahead and set up a system of equations for this. So let's take a look at this first here, right? So two numbers that have a difference of 8. Well, I said my numbers are x and y, so I'm going to say x minus y equals 8. Right? So there's one of my equations. Now my other equation has to add to be 2. So these same two numbers need to sum to 2 or add up to be 2. So x plus y equals 2. So there are my two equations. Now I need to put them together and solve using either substitution or elimination. So let's write these down here. So I have x minus y equals 8 and x plus 2 x plus y equals 2. Now this one's really nice because look at what happens when I add these together. My y's already eliminate. I don't have to do any work to get that to eliminate. So what do I end up with here when I add these together? Well, I'll get 2x equals 10. And then I need to divide by 2 to get x by itself. So x equals 5. All right, so I found one of my numbers, right? That larger number is going to have to be 5. And now I can use substitution to put this 5 back in place of my x here in my other equations to figure out what y is. So if I have 5, putting that in place of x, plus y equals 2, to solve for y, I need to subtract the 5 over. So that means I get y equals -3. Right, now what we have found here, we have that when I take 5 and I add it to -3, I get 2. So 5 added to -3 gives 2 as an answer. Right? And then when I take -3, so -3 subtracted from 5 will result in 8. So I can see that, yep, that is in fact the solutions that I should come up with. Okay, let's try another one. I want you to go ahead and try this one on your own and then come back and see how you did. Okay, so I decided to define my variables as x is the first number, the larger number, y is the second number, or the smaller number. When I set up my two equations, the sum of two numbers is 98, so x plus y equals 98. The difference of two numbers is 42, so x minus y equals 42. And then I decided to solve these using the elimination method. When I did that, I came out with x equals 70, and then I substituted 70 back into my first equation there to solve for y. And when I solved for y, I came out with 28. So 70 and 28 are the two numbers that I'm looking for that will add to be 98, and when I subtract will result in 42. I hope that helped you.